Lesson 7.7, Quadratic Transformations. So today we're going to look at how we can take one of these parabolas, right, and how we can make it fatter or skinnier or move it up or move it down or move it left or move it right or flip it over, right? Those are the transformations that we've talked about. The hardest thing about today's lesson is honestly just the notation. The way that it's written can be super confusing. So I'm going to try my best to make it as clear as possible for you guys, but make sure that you're kind of staying with me, okay? The most important thing to notice before we begin is that they're telling us that f of x is equal to x squared. All right, every single graph has f of x, right? Every single graph has f of x. In fact, every single parabola that's graphed right now, these original ones, you guys, these original graphs are all f of x equals x squared. All right, and if I were you right now, I would go ahead and I would mark each of these that this is f. All right, this is f. This is the original. Hopefully you know that x squared is the parent function, so that might be something else you could be calling these, right? So right now on the graph, just like I said, we have a bunch of x squared graphs, right? F of x equals x squared. Now to really help me out in this lesson today, I actually went ahead and went to Desmos, which we've been practicing with in class, and I typed in f of x equals x squared. So what I have highlighted right here, f of x equals x squared, I went ahead and typed it into Desmos so you can get a really good visual of what's going on here. Okay, so example number 1, g of x equals negative f of x. So the transformation that's happening, right, the thing that's happening here to each of these is I have this negative a value. And let's see what this does to our graph. So over here, I'm actually going to type this in. I'm going to type it in exactly like it looks on your notes, right? It looks like g of x equals negative f of x. And since I already told Desmos what f of x is, it goes ahead and it graphs my new one. Now your calculator does not do this, or at least I haven't showed you how to do this in your calculator yet. So just kind of look at this one to follow along. So take a look at what's happening. My original graph is this U shape. My new graph looks identical, it just looks flipped over. And that's true. That's exactly what it does when we make the a value negative. So let's go ahead and let's just sketch that the new graph looks really similar to the old graph, but it is just flipped over, right? And we call the new graph g, all right, because it was g of x. And that's it. That's all a negative does in the front is it just flips it. Doesn't change the shape. Let's look at the second example. Here we go. This one, g of x is equal to 2 times f of x. This is multiplying f of x by a 2. All right, so it's multiplying x squared by 2. So let's look and see what happens when we do that. So instead of having a negative right here, we're just going to put a 2. Okay, well remember my red graph was the original and my blue graph is the new one. We can see that it still has the same y-intercept, but now how would you describe the blue graph compared to the red graph? Yeah, it's growing faster, so it looks skinnier, right? It looks skinnier. So I'm going to graph it on here, and I'm going to put a skinnier graph and call it G. All right, we probably should have written this down here. Narrower graph for this one, and this one just flipped. That was on the problem 1. So if you put a number in front, right, it's actually changing the shape of A. All right, it's actually changing the shape of A. So you guys might want to make a note, and this is not on your notes, but just kind of take a quick look. What if I put a decimal, like 0.5 or 1/2? Okay, now it got much wider. And we did talk about this before. If I make A a number bigger than 1, it gets thinner. If I make A a fraction, it gets wider. So let's go ahead and let's write this here. A is greater than 1. That equals narrower. And if I say A is less than 1, but still greater than 0, right? We get wider. And of course, we're not worried about the sign, positive or negative, when we say that. Let's look at example 3. This time, I have f of x, and then I just add 5 at the end. So this one's just adding 5 to the end. Do you guys have any predictions about what might happen? You should know it's not getting skinnier or wider, right? The shape is not changing, because that would mean a number is going to go right here. So something else is happening. Well, let's see. Let's take it back to just plain old f of x. And let's at the end, let's put a plus 5. Okay. I can move my graph here a little bit. So my blue graph, it might look skinnier, you guys, just because we can see less of it, but it actually did not change the shape at all. All that happened was here I was at 0, 0, and now my vertex is at 5, 0. Sorry, 0, 5. So my vertex moved up from 0, 0 to 0, 5. So let's sketch this thing. My new vertex is here, and the shape is pretty much the same, and there's my new graph, G. So describe the effect on the graph. We're going to say moved up 5. Actually, I should be more specific. Vertex moved up 5. All the other points did too, but the vertex saying that makes it easier to understand. Okay, so since we did this example, you probably have an idea of what's going to happen now that I have a negative 3 at the end, right? Again, at the end, we're subtracted 3 from the end. Again, the shape should not change because that would mean a number was right in front of f of x, multiplying f of x. It's a number here at the end, so think about what you're expecting to see, and let's see if we actually get that. Let's put in a minus 3 here. Okay, so remember, here was the original 0, 0, and now my vertex is down here at 0, negative 3. Kind of what we probably expected, right? So we're going to put my vertex here. My shape is not changing. All right, so it should be pretty close to the original, so even if my sketch is kind of crappy. And this one is G. So this one moved down 3. We had our vertex moved down 3. All right, flip it over to the back side. We got a couple more examples to look at. So now what we have is we have a change where we have a number in parentheses. So 2 is added to x in parentheses. The parentheses part of that is actually important. Okay, parentheses. Well, we know that a number in the front would change the shape, so that's not happening. We know that a number added or subtracted to the end moves it up or down, so that's probably not happening. So what do you think adding 2 in the parentheses does? Any guesses? All right, well, let's take a look. So we're going to make this look exactly like it did, plus 2. And there we see it, right? There we see it. We see that we've got the same parabola, it just shifted left. So my vertex was here at 0, 0, and now I have a vertex here at negative 2, 0. So we might not have guessed it would move left, but we may have guessed it shifted horizontally, right? So let's go ahead and let's make a quick note here. Describe the effect on the graph. So vertex shifted left 2. So here's my new vertex, and again, the shape should not be changing. The original one was F, the new one we're calling G. And we might make a note that for horizontal change, subtracting moves us right. That's what we just saw. So what do you think adding does? Probably going to move us left, right? It's probably going to move us left. All right. Actually, this is the one we just saw, right? We added 2 and it moved us left. So let's take another second. Let's look at the next one. Again, you may have already guessed what's going to happen. We're going to type in here x minus 5. All right, minus 5. Yep. It totally moved us to the right. My vertex was here at 0, 0. My new one is here at 5, 0. So in our notes, right? We're going to write subtract 5 in parentheses. And we moved, shift right 5. All right. Again, the original was F. My new one is G. So these last two, we are actually going to come up with the equations. So I'm going to look at problem 7 and let's see what we can do here. I'm going to write something that's a little bit, just to kind of help us out. I'm going to write g of x equals f of x. And I'm kind of giving myself some space right here, right? If I needed it to be skinnier or wider or to flip, I would put a number right here. Well, I need it to shift 2 down and 3 to the right. So it looks like I don't need a number right here at all. All right. If I want to make it move up or down, that number here goes on the end, right? That's what we saw earlier. So if I want to make it move 2 units down, then on the end I'm going to put a -2. If I need to move it to the right, then I actually need to have something in here with f, right? F of x. If I need it to move 3 units to the right, okay, well I know this is going to be a 3, and the one in the parentheses was the weird one, so even though I want it to move to the right, which sign moves something to the right? This one when I was subtracting. So if I want to move it 3 units to the right, then I need to have a -3. Okay, so again, it all comes down to kind of knowing where the numbers go and kind of what their effect is on the graph. So my new graph would be 2 units down and 3 units to the right. And really, let's kind of just focus on moving this vertex here. 2 down, 3 to the right, should be right about here. And let's test this. Let's put this in Desmos and let's see if that's what we get. All right, we said f -3 and then a -2 at the end. Yeah, right? It moved 3 units right and 2 units down. Okay, last one. We need a quadratic parent function, which was the x squared, right? Y equals x squared, the blue graph on your paper. Shifted 5 units up and 4 units to the left. This one's really similar to what we just did. Again, I don't need a number in front of f of x because this would change the shape, and nobody's asking me to change shape right now. So we're going to do 5 units up and 4 units to the left. Okay, well 4 units to the left, remember left or right has to go in here with x. Which one moved us to the left? This one, right? This one moved us to the left, which means I need to add. So I'm going to do +4. And that will move me hopefully there to the left. The other one shifted 5 units up. Well, up or down changes go on the end. So we're going to do plus, because it wants us to go up, +5. All right, +5. And let's test it here in my calculator in Desmos. We're going to put in a +4, and then we're going to put in a +5. And this moved me 4 units to the left, and it moved me 5 units up. Right, from my original vertex at 0, 0. All right, so if I were going to summarize this lesson for you guys, I would just kind of help you remember that when you've got this crazy notation f of x and g of x, look at the numbers you're given, look at their signs, and look at where they are. Okay, look at where they are. Numbers on the end shift you up or down. Numbers in the front change your width, right? Skinniness or fatness. And then if you want to move left or right, that number needs to go in the parentheses with x.